Hey folks, so this is Shetz, and we're just going to take a look at the notes, and then we're just going to have you graph sine curve today. I do feel a little lonely without the seniors being here, but anyway, make sure you download the Class Kick Packet Chapter 10, and that'll be for tomorrow, or actually, yeah. Actually for today. I always do these videos a day earlier. So graphs are smooth curves, and they repeat indefinitely in both directions. Our x values, the domain, that's going to be all real numbers. And then notice the scale. When you look at the graph, we're going to be in radians. The x-axis will be in radians. My y's will consist between, because remember, if you remember, notice that my y values, we're only going from 1 to -1. The sine and cosine are always between 1 and -1. We're never going to get out of this circle. So let's go back to where we were. So my y values will consist between -1 and 1. You don't have to worry about this too much, scaling purposes. But for the period, that is one cycle of the curve until the pattern starts to repeat. And our period for sine and cosine will begin at 0 and go all the way out on the x-axis to 2 pi, or 360 degrees. So 2 pi minus 0 would be 2 pi, and that is one period for both sine and cosine. Critical points. Well, that just means where the graph crosses the x-axis. And notice on all these values, y is 0. The sine curve has 3 critical points. The 0, 0, pi over 2, 0, and 2 pi over, 0. Cosine curve has x-intercepts of pi over 2, 0, and 3 pi over 2, 0. I know all these notes will be more understandable to you as you go ahead and graph. The maximum value, well, that's our largest y value. The sine that occurs at the sine curve, pi over 2, 1. Notice how high it is, it's a 1. And the cosine curve happens twice at 0, 1, and 2 pi, 1. Minimum value is the smallest value. For the sine curve, it's 3 pi over 2, -1, and the cosine is pi, -1. And again, this will be more understandable to you as you graph. Well, when you divide something into 4 regions, that's called quartile. Get it? Quarts. So when we take our period, which is 2 pi, and divide that by 4, we get quartiles of pi over 2. So the quartile length is pi over 2. All right, well, let's get the graphing. And here's, what is it, slide 4. So I'll help you out here. I'll start this for you, and all we're going to do today is finish it. So the sine of 0, that means, if you think back to this curve, right there, there's my sine of a 0 at 0. All right. We're going to put a dot there. Okay, then at pi over 6, well, hopefully you don't need this anymore, but there's pi over 6, and it's 1/2. So If this is 1 and that's 0, about halfway, I need to be pi over 6, about there. Might be a tad too high. Now, if you recall, I told you to memorize certain numbers like root 2 over 2. And that is 0.7071. So at pi over 4, my sine curve is a 0.7, so I need to be a little bit higher than this 1/2 right there. Okay, and at pi over 3, I'll show it to you. Here's pi over 3. Again, this should all be memorized. You shouldn't be really looking at this chart. This is root 3 over 2. So we know that's 0.8660. And I'll put a orange dot there to keep everything color-coded. 0.86. Okay, that's good enough. And now, straight up, my y value is 1. The sign means y's. And it's a 1, so guess what? There's one of my maximum points. Now, I know this doesn't look perfect, but this is what the graph is going to do. Smooth, rounded curves. What I'd like you to do is finish up this graph. And I'll give you a hint. I'll do it a little bit lighter. I should have crossed right there. It's kind of hard to make a nice drawing with my mouse. But that's what the rest of the graph is, and I want you to fill in this chart down here. Okay, folks, you have a great day. I'll see you. Bye.